Is it possible to hack Python's print function? Note, this question is for informational purposes only. I am interested to see how deep into Python's internals it is possible to go with this. Not very long ago, a discussion began inside a certain question regarding whether the strings passed to print statements could be modified after slash during the call to print has been made. For example, consider the function. Now, when print is run, then the output to the terminal should display. Notice the word cat has been replaced by the word dog. Something somewhere somehow was able to modify those internal buffers to change what was printed. Assume this is done without the original code author's explicit permission, hence, hacking/hijacking. This comment from the wise at Abernert, in particular, got me thinking. There are a couple of ways to do that, but they're all very ugly, and should never be done. The least ugly way is to probably replace the code object inside the function with one with a different co_const list. Next is probably reaching into the C API to access the str's internal buffer. So, it looks like this is actually possible. Here's my naive way of approaching this problem. Of course, exec is bad, but that doesn't really answer the question, because it does not actually modify anything during when slash after print is called. How would it be done as that Abernert has explained it?
First, there's actually a much less hacky way. All we want to do is change what print prints, right? Or, similarly, you can monkey patch this .stat instead of print. Also, nothing wrong with the exec, get source, idea. Well, of course there's plenty wrong with it, but less than what follows here. But if you do want to modify the function object's code constants, we can do that. If you really want to play around with code objects for real, you should use a library like bytecode, when it's finished, or byteplay, until then, or for older Python versions, instead of doing it manually. Even for something this trivial, the codetype initializer is a pain. If you actually need to do stuff like fixing up limtab, only a lunatic would do that manually. Also, it goes without saying that not all Python implementations use Python-style code objects. This code will work in Python 3.7, and probably all versions back to at least 2.2 with a few minor changes, and not the code hacking stuff, but things like generator expressions, but it won't work with any version of IronPython. What could go wrong with hacking up code objects? Mostly just seg faults, runtime errors that eat up the whole stack, more normal runtime errors that can be handled, or garbage values that will probably just raise a type error or attribute error when you try to use them. For examples, try creating a code object with just a return underscore value with nothing on the stack, bytecode b'(s\0 for 3.6 plus, b's before, or with an empty tuple for co_const when there's a load_const0 in the bytecode, or with var names decremented by 1 so the highest load_fast actually loads a freever/cellular cell. For some real fun, if you get the limtab wrong enough, your code will only segfault when run in the debugger. Using bytecode or byteplay won't protect you from all of those problems, but they do have some basic sanity checks, and nice helpers that let you do things like insert a chunk of code and let it worry about updating all offsets and labels so you can't get it wrong, and so on. Plus, they keep you from having to type in that ridiculous 6-line constructor, and having to debug the silly typos that come from doing so. Now on to number 2. I mentioned that code objects are immutable. And of course the consts are a tuple, so we can't change that directly. And the thing in the const tuple is a string, which we also can't change directly. That's why I had to build a new string to build a new tuple to build a new code object. But what if you could change a string directly? Well, deep enough under the covers, everything is just a pointer to some C data, right? If you're using Python, there's a C API to access the objects, and you can use C types to access that API from within Python itself, which is such a terrible idea that they put a Python API right there in this libc types module. Smile, the most important trick you need to know is that it X is the actual pointer to X in memory, as an int. Unfortunately, the C API for strings won't let us safely get at the internal storage of an already frozen string. So screw safely, let's just read the header files and find that storage ourselves. If you're using Python 3.4 to 3.7, it's different for older versions, and who knows for the future, a string literal from a module that's made of pure ASCII is going to be stored using the compact ASCII format, which means the struct ends early and the buffer of ASCII bytes follows immediately in memory. This will break, as in probably segfault, if you put a non-ASCII character in the string, or certain kinds of non-literal strings, but you can read up on the other 4 ways to access the buffer for different kinds of strings. To make things slightly easier, I'm using the pythoninternals project off my GitHub. It's intentionally not pip installable because you really shouldn't be using this except to experiment with your local build of the interpreter and the like. If you want to play with this stuff, it is a whole lot simpler under the covers than STR. And it's a lot easier to guess what you can break by changing the value of 2 to 1, right? Actually, forget imagining, let's just do it, using the types from pythoninternals again. Pretend that code box has an infinite length scroll bar. I tried the same thing in IPython, and the first time I tried to evaluate 2 at the prompt, it went into some kind of uninterruptible infinite loop. Presumably it's using the number 2 for something in its REPL loop, while the stock interpreter isn't.
Monkey patch print. Print is a built-in function, so it will use the print function defined in the built-ins module, or _built-in_ in Python 2. So whenever you want to modify or change the behavior of a built-in function, you can simply reassign the name in that module. This process is called monkey patching. After that, every print call will go through custom_print, even if the print is in an external module. However, you don't really want to print additional text, you want to change the text that is printed. One way to go about that is to replace it in the string that would be printed. And in D if you run. Or if you write that to a file. test_file.py. And import it. So it really works as intended. However, in case you only temporarily want to monkey patch print, you could wrap this in a context manager. So when you run that, it depends on the context what is printed. So that's how you could hack print by monkey patching. Modify the target instead of the print. If you look at the signature of print, you'll notice a file argument which is sys.stout by default. Note that this is a dynamic default argument. It really looks up sys.stout every time you call print, and not like normal default arguments in Python. So if you change sys.stout, print will actually print to the different target. Even more convenient that Python also provides a redirect_stout function from Python 3.4 on, but it's easy to create an equivalent function for earlier Python versions. The downside is that it won't work for print statements that don't print to sys.stout, and that creating your own stout isn't really straightforward. However, this also works. Summary. Some of these points have already been mentioned by Ada Barnett, but I wanted to explore these options in more detail. Especially how to modify it across modules, using built-in /_built-in_, and how to make that change only temporary, using context managers.
Let's combine this with frame introspection. You'll find this trick prefaces every greeting with the calling function or method. This might be very useful for logging or debugging, especially as it lets you hijack print statements in third-party code.
A simple way to capture all output from a print function and then process it is to change the output string to something else, for example a file. I'll use a PHP naming conventions, ob_start, ob_get_contents. Usage. Would print. Hi John by John.
리플 유언드 75 플리즈 컴시더 서브스크라이빙